Okay, so it seems that each individual photon has a very small amount of energy, but how much energy is actually in the light coming into our smartphone camera? Well, to work that out, let's imagine a typical low light situation. Let's imagine I'm trying to take a photograph of someone out in a garden lit from a distant light bulb. So we're going to have a light source, a light bulb. Some distance away we're going to have a person. And then we're going to have a camera. So we're going to work out how much light energy comes out from here. And as that will spread out over a larger and larger volume and get weaker and weaker, some of it will hit the person over here and bounce off them. And an even smaller amount will land at the camera. And then we've got to work out how much will fall on a particular pixel in the detector. So we're going to have to go through all these steps to work out how much energy is getting to our camera pixel, and then we can compare that with the energy per photon, and that will tell us how many photons are going to arrive per pixel. So let's look at the first step. What is the energy output of a light bulb typically? Well, there's an old-fashioned light bulb, an incandescent tungsten filament light bulb, and a typical one of those is about 60 watts. You can go to your local hardware shop or supermarket and see that. Nowadays people are using a lot more LED lights, and they might be typically, I don't know, 6 to 9 watts. But that's the power you put in, how much electricity it uses. It's not the amount of light that comes out. We know that light bulbs, even LED ones, get quite hot. That's telling us that a lot of the energy is going in the form of heat, not in the form of light. If you look up on the web, you can find that 60 watt light bulbs are about 2% efficient. So about 2% of the energy is in the form of light. With LEDs, it's about 10% efficient. They're much better than incandescent light bulbs. They're still not very good. So if you multiply this by 2% or that by about 10%, you're talking at about 1 watt of light either way, because these bulbs are considered roughly equivalent to their light output. So that's one way to estimate it, and we're getting figures of about a watt for the amount of light energy put out by a typical light bulb. However, it's always good to double check. And if you look on the web or in your hardware shop, you'll see that the light put out by a bulb is often measured in lumens, and you can see the number of lumens put out on the packaging typically. Now a typical fluorescent light bulb puts out about 450 lumens. The definition of a lumen is a bit complicated, but roughly speaking, 1 lumen, if the light is at the wavelength the human eye is most sensitive to, which is yellow, about 0.55 microns, is roughly 1/700 of a watt. So multiply these two figures together and you end up with a power of about 0.5 watts from a typical light bulb, which is not too far off this. So the details will vary depending on exactly, does the light spread out in all directions, what wavelength is the light, but roughly speaking we're talking about perhaps a half a watt to 1 watt for a typical light bulb. So let's call it, for ninja purposes, roughly 1 watt. So that's our first step. We'll then need to go on and work out how much gets here, how much gets here, and how much gets to a pixel.